Okay, students, welcome to the class. So, in this class, the power system protection. So, first, what is mean by power system? So, in the power systems, deal with the generation, transmission, and distribution. Okay. So, in the power system, generation, transmission, and distribution. First, we have learned about the generation. So, in the generation, we have the thermal power plant, tidal power plant, nuclear power plant, and diesel power plants are there, right? So in the transmission system, okay, so in the transmission system we have know about the what are the types of the transmission systems. Okay, the transmission system, medium, short, okay, long transmission line types. Okay, what are the parameters affect the transmission line? Okay, so how it is will be improved by the transmission system. Okay, efficiency. Okay, what are the losses we occur that have studied in the transmission system. In the distribution we having the substations. Okay, what are the equipments we have in the substation, where we are placing the substation, what are the types of the substation, what are the voltage levels we having this distribution system. Okay there. So let me take the what are the first generation. So in the generation we are having the 11 kV. So in India we are having the 11 kV generation, and the some cases will having 13.3 kV generation also there. And the most of the other countries will having the 11 kV to 22 kV generation. And in India we are having the 11 kV, and some of the that is a 13.3 kV. And here for generating the 11 kV and the 22 kV is that, so why we are going to generate this 11 kV that to 22 kV? Okay, why not beyond the 33 kV means? So here is the first thing is the economic cost. Okay, so the economic cost for generating of the power supply for the 11 kV is the less compared to the other voltage levels. And the copper conductor, so the copper conductor it's required for the generating of this voltage is less compared to the 33 kV. Okay, so for this reason, first main we are going to generate the power supply, that is 11 kV is. So if we increase the voltage levels beyond this one, so what will happen? We need the copper conductor for generating. And another thing is the mainly issue, that is the insulation. So here we are why we are problem take place in insulation means, so first that here in the insulation system we are placing the copper conductor in the stator. So the stator which will having the state armature rear. Okay, so the armature is the copper conductor place, right? So whenever the insulation take place, okay, if it's beyond this some voltage levels, okay, so if you be on the 22 k, what happened, the insulation method, okay, what are the types of insulation metals we having, so protection, so that will not supported by this insulation. So that is a major cause. And for this reason we are going to generate that is the 11 kV only. Okay, so this is the generation. And coming to the, okay, so first talk about the what is the protection, what is meant by switchgear. So here in the some cases we have studied about the switchgear protection is the same relate. Okay, so power system protection and the switchgear equipment. So in our chapter, let me see the uh, so protective equipment and switchgear. Okay, so in the chapter 1 we are having the protective relays or current protection. In the chapter 2, in the chapter 3 pilot relay scheme, static relays, and the last one the circuit breaker. So here the names we will see in the books names or the general subject names. So in the, that is power system protection. So power system protection and switchgear. So there's a small difference between the power system protection and switchgear. Okay, so power system protection. Okay, so protective elements. What are the protective element? What are the switchgear equipment? Okay, so if you see the difference, okay, then only we can know which one is the switchgear equipment, which one is the protective equipment. Okay, so the difference is that the protective equipment which will sense the faults. Okay, the protective equipment is which will sense the fault. So the protective equipment which will sense the fault and they give the signal to the switchgear equipment. Okay, so here the example for the protective reserve, that is a relays. So relay will sense the fault, okay, not the isolate the fault. Okay, so it will only sense the fault and give the signal to the circuit breaker. Here the switchgear equipment. So a switchgear equipment is that which will it will isolate the, okay, so which will isolate the healthy section to faulty section. Okay, which will isolate the healthy section to faulty section. Okay, so here switchgear equipment, that the current transformer, protection transformer, sorry, potential transformer, circuit breakers, isolated switches. So is all that common to the switchgear equipment. So protective equipment which will sense the fault. Okay, so it will sense the fault and give the signal to the switchgear equipment. So it will set the fault. Okay, so it will isolate the from healthy section to faulty section. So this is the different, that is a protective equipment which will sense the fault. Okay, the switchgear equipment which will be isolate the from fault section to healthy section. Okay, yeah. So first, why we need the protective equipment and switchgear equipment. Okay, first we'll talk about the why we need. Okay, so what is the need of the protective equipment in the power system. Okay, so in the power system, so why we need, okay, so what is the need of the protective systems. So what is the need of the protective elements in this one. So here's the thing is that, so we're having the power system equipments, we're having the different types of the protective elements we are using. So first we'll talk about the here the transmission line. So in the transmission line we are having the different types of the line. So 220 kV line, 400 kV line, 132 kV line. So here, so what will happen whenever the any unwanted conditions take places, that the loss will be occurred. Okay, so due to the short circuit of the two lines, okay, the fault is occurred. So due to the variation of thunderstorms or flashover of the failure of the insulation disc also plays the fault, right? So first we have to know about the what are the types of the fault. Okay, so here, so we have the to protect the equipment. Okay, so we have needing the some protective gear equipments are there. Okay, so in that one, first what are the types of fault which will occur. First here there are the two types of the faults here. First one is symmetrical faults, and the second one asymmetrical faults. Okay, so symmetrical faults, asymmetrical faults are there, the two types. So which one, the symmetrical faults. Okay, so in the lines we having the three lines, right? R, so R phase, Y phase, B phase. Okay, so let me take the, that is I consider the hazard, it's a one line. So the one line, okay, another we having the R, Y, B, R, three phases. Okay, so let me take the three phases lines. Okay, if you involve the all the three phases, okay, if you involve take the LLG, okay, so ground, if you take the ground, okay, so if it is G, so if you involve the all three, okay, so all the three lines is and along with the ground, so that's all coming to the symmetrical faults. Okay, the faults which will involve the all the phases, okay, that is a LLL or LLL Okay, line to line. Okay, all triple L faults is called as the, and triple L G faults are called as the symmetrical faults and asymmetrical faults. So each will involves the one of the two phases. Okay, if it is fault is occurred, so it will only take place the one LL or LG. So here the which will involve the one or two phases. Okay, which will involve the one or two phases without, with or without ground. Okay, these are the examples we have. That's the LG fault, LLG fault. Okay, so these are types. That is a LG, LL, LLG faults. Okay, these are called as the asymmetrical faults. Okay, so in that mostly, so there are the 10 types of faults that occur on the power system network. Okay, so there are the total 10 types of faults we have. Okay, there are the 10 types of faults that can occur in the power system network. Okay, so these are the symmetrical. Okay, first we'll go for the symmetrical faults. Okay, so how it is occurred, okay, in the power system network. Okay, first we'll take the one transmission line. So here's the one bus bar, and here we're having the switches. Okay, let me take the line. Okay, which are connected to the lines of the another phase. Okay, here are the switches we have. The circuit breaker, let me consider these are the isolators, are the are circuit breaker switches, and here let me take the earth switch. How the symmetrical faults occur, okay, in the transmission line system, or in the substation or the network. So here is the one considering the one transmission line bus bar, and here we have the circuit breakers, and here are the earthing switch. So whenever the circuit breaker is turned on, okay, so when the circuit breaker is closed, so we have to open the earthing switch is as open. Okay, whenever the circuit breaker is closed, we have to open the earthing switch. So if it is simultaneously switching on the both at the turn on, so what will happen, it will take place is the LLG fault. Okay, so all the sessions will be all goes to the ground. Okay, that's why here the fault will occur. So whenever the all LG, okay, so all else will turn on, and if the simultaneously everything switch is also turned on, so what will happen, it will causes the fault. Okay, so this is how it will occur in the symmetrical faults. So we can say that in the formally, so it occurs when line is energized and everything switch is advancedly kept on. Okay, so here when the line is turned on, okay, when its line is energized and earthing switch inadvertently kept on. Okay, this is way how symmetrical faults is occurred. The causes is that, okay, so whenever the transmission line, the isolator, the circuit breaker switch is turned on, okay, we have to keep open the earthing switch. Okay, if we kept on close, both turned on, so what will happen, all the L is goes to the ground and it causes the LLG fault. LLG faults. Okay, so this is one of them. Now let me take the how is the LG fault is occurred, that is the asymmetrical faults in the system. Okay students, so here we'll talk about the symmetrical fault. Okay, let me talk about the how the as asymmetrical faults. Okay, so let me talk about the asymmetrical faults which will causes the more dangerous to the transmission line. Okay, so most occurred faults, okay, that's the asymmetrical faults. And the symmetrical faults occur with the it's very less. Okay, so because it's the while switching on the both earthing switches and isolated switch on is the rare cases. Okay, so the most occurred faults is are the asymmetrical faults. Okay, here let me take the LG. Okay, how the LG fault is occurred. Okay, so line to ground fault if we take. Okay, let me take the live example. Okay, which we are seeing the date live. That is the if. Okay, so here if you take the one transmission line, okay, tower. Okay, if you take the one transmission line tower, so here we are having the cross arms, right? So the cross arms we are having the string insulator or disc type insulator which are having. So here this will having the, it will carry the conductor. Okay, so let me take the 132 kV transmission line, suppose if you consider. Okay, here the number of strings which will having the, so first each string, okay, so each disk is carries the 11 kV voltage, right? So here the number of disk, okay, so the number of disk which will for protective, okay, so the number of disk which will need in the string is suspension type insulators. So is so how we are calculating that? So if you calculate the number of disk, okay, so if you take the number of disk is required, so if you take the here the voltage that's the 132 kV, and the for phase that is the root 3. Okay, so here each having the 11 kV. Okay, so here the it will come the around 6.97 I think. Okay, so here this we need the 6.9 number of days. Okay, but we are not placing the this number of light. Okay, so we are along with this one. Okay, so which will place in the, okay, so by safety, okay, if it is one of the disk is failed, okay, if it is, if considering the one of disk is failed, so at the time we have to place the another disk. Okay, so for this reason, so we'll considering that as a, that term is called as a safety. Okay, for the factor of safety. Okay, so factor of safety factor, so that is a 1.5 for the string insulator. So here that is the, if you multiply the 6.95 into the 1.5, will get the 8 to 9 number of conduct. Okay, so for this pin, so we have to place the, okay, 8 number of or 9 number of the string insulator in this one. Okay, so if we place that, okay, so if so the voltage, okay, so the voltage which is required, that is the 11 kV voltage is that for each string, right? Each string. So everything suddenly due to the thunderstorms, okay, so due to the lightning, so what will happen at that time? So due to the lightning conditions, what happened, the here the rating, okay, so the voltage rating, that is 132 kV, is not supposed to withstand the voltage. So at that time what the voltage rating will be suddenly rises, okay, at that time. Okay, the line, okay, so the line which will be causes the disk insulator, okay, the string insulator which will cause the flash over between the line to insulate cross arm. Okay, so that will be the cross arm which will connect to the ground. Okay, so the cross arm which will connect to the, it will connect to the ground, right? So at that time what will happen, the LG fault will occur. Okay, so let me take the again. So here whenever the heavy wave fault, okay, so when heavy voltages, okay, the thunderstorms are due to the lightnings, okay, so if it is a heavy faults is occurred on this cross arm, okay, so what will happen, the current which will flow through this disc, okay, so any line if they affected that one, okay, lightning, so at that time higher voltage will be take places, and due to this, so the current, okay, the withstanding capacity of the insulator will not have to, that is 11 kV, but if the higher if go take places, at that time it will be short the voltage, okay, it cannot withstand that voltage, so at that time what will happen, it will goes to the flash over between that line to cross arm, okay, at that time, so at that time the cross arm which is connected to the ground, okay, due to that, that will be produce the LG fault, okay, that type of fault is called the LG fault, okay, line to ground fault. So the how much current, okay, the how much voltage it can withstand for the each thing, okay, the maximum value if it is how much value it can withstand, okay, that is the, if we, that is the, okay, for each string, okay, that is the, so for line, so 132 could be root 3 for each line, and root 2 times of the voltage it can withstand, okay, if the maximum is this voltage, what will happen, it will be flash over the line, okay, due to that at the time also it will take place the LG fault, okay, okay, due to the variation in this, okay, this is one type of the LG fault. So how is the LLG fault, it will occur, that is if there is any variation between the line, okay, due to the wind or due to the kite, okay, so we also know that, okay, so kite strings, okay, due to the kite string the LL faults, okay, so we are seeing the distribution system, the LL fault, okay, and so what will happen when the kite, okay, so in the kite season, so the kite string which will be take places in which the two lines, okay, due to this here the kite string also take causes the damage of the uh, occurrence of the LG fault, okay, or LLG fault, okay, this one, and another thing that is a bud, okay, so the bud also is the sometimes this will take place the in between the line, okay, this is one of the causes of the, that is a LL faults, okay, so the fault, okay, so the LL fault or LLG fault, okay, occurrence due to the birds, okay, sorry, due to the birds or kite strings or tree limbs, okay, if there is any tree limb fault on the line, okay, it is also one of the cause of the LL fault, okay, these are the type. So the LG fault it will occur due to the flash voltage, okay, the occur with the flash over voltages or failure of the insulator, okay, these are the causes of the LG fault, LL and LG fault, okay, these are it. So see if the fault is occurred, okay, so what will happen, okay, so what are the main objective, okay, so if it is a fault is occurred, okay, what will the consequence in the transmission line system or the power system are that, okay, so that is the one thing. So, so here, so the two main damages because of the fault are, okay, so due to that, that is the first thing is that the thermal, okay, that the first thing is the thermal damage. So what will happen whenever the L, okay, LL or LG faults occur, okay, so it will be increasing the transmission line temperature, okay, so due to that the conductor, the insulating medium which it is having the different types of insulating medium we are using. Okay, so let me take the class. Okay, there are the different types of the classes of insulator, that's the A to G. Okay, so at the time, due to the variation in the uh, type of the faults, also the if it is the, you have to place in the different types of the insulating medium. Okay, so here what will happen in the thermal damage will occur, okay, due to the fault. Okay, it will occur slowly as a related to the temperature. Okay, so it's a depend upon the thermal withstand capable of insulation, which is depends on the okay. So why that okay, so this thermal damage occurs slowly. Okay, so thermal damage occurs slowly because of the insulation type area. Okay, so because of the insulation failure or insulation temperature withstand capability. Okay, so we have many different types of insulating media that is classified into A to C. Okay, so for that one, so if we are using the plastic or PVC, glass, or okay, so all are confined into different classes. Okay, so for that one, if that okay, so that depend upon the which type of material we are using. Okay, so that, so the fault which will causes in the thermal damage slowly. Okay, it's depend upon due to the insulation. Okay, so it depend upon the insulation temperature capability. Okay, next another fault, that is the okay, that is another damage. Okay, one of the damages, that is the thermal damage. Another is that is the electrodynamic. So another damage will occur, that's the electrodynamic damage will occur. So these are two types. Okay, so the electrode type, so it will be taken the, it will take the long time. Okay, but it will cause the few years. Okay, so here the electrodynamic damage is due to the large current would depend on. Okay, so it will cause the large variation. Okay, so in the electrodynamic damage, okay, so the pulling force is generated due to the large current would destruct the whole. Okay, so it will cause due to the large current flow. Okay, for the certain minute or few minutes. Okay, okay, so here the thing is that okay, so it will, so if it is a tripping, okay, if it suddenly, if the three lines are suddenly started, okay, so what will happen here, it will damage the, it will increase the current. Okay, the short circuit current which will flow throughout the line, and it will causes the higher damage. Okay, it will cause the larger throughout the line. Okay, whatever the transmission is there, okay, it will flow the all the line, and it will cause the whole damage of the power system. Okay, so this type, okay, it will, that is a, in this damage it's the magnitude of the current. Okay, in this damage, so the magnitude of the current which will high. Okay, uh, 10 to 20 times of the load. Okay, the mag in this type of damages, the current rating having the 10 to 20 times of the full load condition, which will be need the instantaneous tripping. Okay, so if it is thermal, okay, so if it is thermal damage, okay, so it will take place the time. But here the electrodynamic type is so it will instantaneously, we have to switch it on. Okay, we have to instantaneously tripping is required, so we have to, if the fault is occurred, okay, so electrodynamic, uh, so if a fault is occurred, okay, so electrodynamic, so we have to take care the instantaneously we have to protect the equipment. Okay, otherwise it will goes to the collapse of the grid. Okay, so for this reason we have to need the instantaneous stripping is needed. Okay, it will require the instantaneous stripping. So for this video, so there are the two types of the fault damage occurred. There is one is the thermal type. Okay, in the thermal type, what will do slowly take place. Okay, so if it is a LG faults or LL faults, so what will happen? So it will slowly damage the equipment. Okay, but if we take the electrodynamic damage, so it will causes the need the instantaneously. So or else it will cause to collapse the total grid. Okay. So what are the probabilities? Okay, so here how much? Okay, so that we have talked about the symmetrical asymmetrical fault. So how much probabilities is occurrence of the LG fault, LL fault? Okay, so if taking as a, how much percentage of the fault occurrence chances in this one? So let me taking the equipment name, okay, and percentage of occurrence of fault. Okay, how much of fault is occurring? Okay, so if you take the overhead lights, so if you take the overhead transmission line, so there's a chance of the 50% of faults is occurring. Okay, so there's a chance of the 50% of the fault occurrence probability in the different elements and underground cable. So in the underground cables, so we're having the 10% of chances is there, and switching of the CTs and PTs. Okay, so switching of CTs and PTs, due to that there is 15% of chances, and the power transformer. Okay, so if you take the power transformer, there is a chance of the 15 percentage, and if take the miscellaneous, okay, remaining, so there is a chance of the 10%. Okay, so these are the chances of the probability of the fault occurrence in the power system. Okay, so here the whole transmission line and the fault occurrence, due to the many things will occur. That's the, if you take, okay, how much which type of fault is mainly occurred. Okay, if we take here the probability, so most occurrence fault, that is the LG fault in the transmission line, that is the 80 to 90% of chances in there. Okay, and LL fault if we take, so 6 to 10% of chances, and LLG fault 3 to 6 percentage, and LLG fault 1%. Okay, these are the fault occurrence chances in the transmission line. That is the 80 to 90 percentage. That is the most occurrence faults. That is in the transmission line system. That is the LG fault. And if you take the LL fault, that's 6 to 10 percentage, and LLG fault 3 to 6 percentage, and LL faults is that is the 1% of chances. Okay, these are the fault occurrence probability in the transmission line system. Okay, there's the chances. And not only this, okay, the faults is a category is based upon their switching set. Okay, so based upon the different categories. Okay, there's another category is that is the transient fault. Okay, transient fault and permanent fault. So these are the two types of the fault. So which will transient means instantaneous time. Okay, the time taken is very less, so it will automatically out of the certain time. And if take the permanent fault, so it will have the longer duration to damage the total equipment of the system. Okay, so these are the, so it the transient fault, okay, it shall have the temporary. Okay, so automatic out of the few cycles. Okay, so why where it will occur? Okay, it will occur between the two phases. Okay, power arc between the two lines or two phases. So the power arc between the between two phases, and other the flasher voltage. Okay, flasher will go to the or voltages in the insulator. Okay, this are taken. And if you take the permanent faults, okay, this will have remained longer duration and damage the equipment. Okay, so this will have the different types. That is the symmetrical faults. Okay, this is the one permanent faults having the symmetrical faults. Okay, and occurrence of fault causes. Okay, so if it is faults occur, okay, what are if it affected? That's one is the interruption in the power line supply. First thing is that is the interruption. Okay, so interruption in the line, and if take the some stuff like revenue loss. Okay, so revenue lines for the consumer and the transmission line over, and the loss of synchronism. Okay, so if the loss of synchronism, the transmission line system and the generating process, so it will be cause a huge amount of losses in the system, power system. Okay, that will be, so if it is a loss of synchronism occur, so it will damage the grid. Okay, so it will cause the damage of the grid, failure of the grid also take places due to the fault. Right? So and also it damage of equipment. So okay, and also serious hazard to the persons. Okay, these are the fault. Okay, cause. So if it is fault affected conditions, these are the there. So in this class we have know about the what are the power system protection. What are mean by switching gear equipment. Okay, so in the in this class we have discussed that the types of fault. Okay, why it's a faults occurred, what are the types of fault, that is symmetrical faults, asymmetrical faults, and another category that is the in the asymmetrical faults, LLG faults. Okay, so what are the faults consequences? There's a thermal damage will occur, what I mean by electrodynamic damage, and the another category, the transmission faults, is the transient faults and the permanent fault. Okay, that we have discussed in this, and this is the introduction to the protector. Okay, so these are the basic knowledge. Okay, so we have to require for the why we need the protective equipment in the power system is that is to avoid the power system. Okay, to avoid the losses and faults in the power system. Okay, we have to know about the where we are the faults is occur. Okay, how it is occurring. Okay, so at that time only the designing of equipment. Okay, the protective equipment which are required. Okay, for different area where we are occurring uh, the LG fault is occurred, where it is a LL fault is occurred. Okay, what are the factors in occurrence of the transmission line? Okay, that's another choice. Okay, so these are the need for the transmission line, the protective system and the switch gear equipment. Okay, so protective system is nothing but the which will sense the fault. Okay, so it will sense the fault and give the signal to the switch gear equipment like isolators and circuit breakers. Okay,